Page 4 now. We're just two questions, which I got from Alex. Oh, notice the directions. Find the equation of the quadratic function f, whose graph is shown below. And we're given clues of the vertex and a point that the parabola goes through. So, you might start with this idea. Remember, the function written in that form that we've been using today is some number a, and a tells us whether the parabola opens up or down. This is opening down, so our hunch is this is going to be a negative number. And then what goes in here? X minus the x value of the vertex. Well, the x value of the vertex is 2. Why don't we just put that in there? There's something. And what goes outside? Plus k, k being the y value of the vertex, so I can write plus 7. Well, here's what we've got so far. Some number a times x minus 2 squared plus 7. This looks like almost the complete answer, except we don't have the number for a. Well, what can we do with the 3, 4? This is a pair of x and y values that have to work in the equation when we have the true equation with the correct a value. And by work, I mean when you put in 3 for x, the equation has to give you back 4 for y. So what if we just put those numbers in right now? Put in the 4 for y, leave a alone for the moment, put in the 3 for the x, and remember the minus 2 and the plus 7, that came from using the vertex. Everything's a number except a. We can squeeze the value of a out of this right now. I can rewrite this 4 equal 3 minus 2 is 1. I didn't even need a calculator. 1 squared is 1. So if it's just a times 1, we might as well just write a. And then if I take away 7 from both sides, I've got negative 3 for a, and I'm ready to write my answer. I can say f of x is negative 3 x minus 2 squared plus 7. So again, to rehash, I started by inserting h and k from looking at the vertex, and then I used the given point for values for x and y, x there and y there, which allowed me to solve for a. And if I want to check my answer, take the graphing calculator and put my answer in. There's the answer I got, negative 3 x minus 2 squared plus 7. And if I hit zoom 6, I get this graph. Okay? It's supposed to have a vertex at 2, 7. Hit the trace key and punch in a 2. Does that look like it's at the vertex? 2 and 7. I put in the 2. The equation, or the calculator gave me back the 7. If I go a little to the right, see the y value is less than 7 now. Go a little on the other side, the y value is less than 7. Go put in a 2 right at the vertex. And if I use a 3 for x, what happens? I get the required number 4 for y. Nice, huh? Let's try the next one. We're given this picture, and it's called g of x, and the vertex is at negative 4, negative 4. So I can begin by writing g of x equals a times x minus the x value of the vertex. So minus a minus 4 will make that plus 4 squared. And then plus the y value of the vertex on the outside. I can write plus negative 4, but I'm just going to write minus 4. That's the vertex point. Don't get the two confused. How do you know which one's the vertex? The vertex is where the graph changes direction, or it's the minimum or maximum. Use this for x and this for y. 4 for y, or the function value. And then a times negative 6 for x plus 4 squared minus 4. And we're expecting a to come out positive this time since this parabola opens upwards, right? So I have 4 equals a. Negative 6 plus 4 is negative 2. And negative 2 squared is positive 4. Okay? And if I add 4 to both sides, it's going to say 8 equals a times 4, or I'll just write 4a. And dividing both sides by 4, I get a equals 2. And look, if I go over 1 and up 2, and then over 1 and up 6, I do wind up there, as we used on the previous page. So it does work very nicely, fits in with everything else we talked about. So what's my answer? Let me write it way up here. G of x is 2x minus 4. We write plus 4 squared and minus 4 on the outside. Okay, that's the end of page 4. Thank you very much.